Welcome back to the GCSEMathsPro YouTube channel. In today's video, we'll be going through the paper 2 from the June 2022 series, which is calculator. So do make sure as we go through this that you do have your calculator, and specifically your scientific calculator, not just your phone. You want to be practicing this with the actual calculator that you'll have on the day in the exam. So if you wanted to see paper 1, we did go through that on Monday. It is unfortunately in 2 parts because of some technical difficulties, so make sure you check out both parts. In this paper, all of the topics that I have my own videos for that come up in this paper are also linked in the description, so feel free to have a look at those as well if you want to go through anything in a little bit more detail. And let's just get straight into it. Okay, so question 1, we've got a few different parts. So part A, simplify x cubed and then all of that to the power of 5. So this is index laws, and it is our third index law, the one where you've got the brackets, which means we do have to multiply the powers. So literally, all you're going to do is obviously keep the x as the base, multiply 3 and 5 to give you 15, x to the power of 15. Part B is just some expanding of single brackets and then obviously simplifying, collecting the like terms. So we're just going to multiply out the brackets. You obviously get 4x there plus 12 and then plus 28. And then this one would be minus 14x. So be careful of any of those symbols. So I've expanded it. That's obviously step 1. Step 2 is then to simplify. So you can see that I've got some x's and just some numbers. Obviously 12 and 28 add up to make 40. And then 4x minus 14x gives me minus 10x. It doesn't matter if you wrote it the other way around. If you put minus 10x plus 40, that's also the same thing. Whichever of those two options is fine. Yeah, so the first few questions are normally pretty nice, so that's good. Part C. I apologise if there's any noise in the background, hopefully it's not too bad. We've got factorise fully 15x cubed plus 3x squared y. So this is just going to be single brackets. This is just going to be single brackets. So we're going to pull out common factors. That could be numbers, that could be letters, both. In this case, looking at the numbers, 3 is the highest common factor, isn't it? Between 15 and 3 is 3. Oh, and then we can also pull out... Sorry, I have to keep pausing every time they're trying to break up the floor. Yeah, so, well, not just x though, we can pull out an x, but also between x cubed and x squared, the highest is x squared, isn't it? They both have x squared at least. So we can pull out that. Now they don't both have y, so that's obviously not common. Then on the inside, how do I get back to 15x cubed? Well, I'm missing 5 times 3 to make 15, and obviously then another x to make x cubed. And then the other term, we're just missing the y. Okay, so it could be letters and numbers that you can pull out as a common factor. Question number 2. Describe fully the single transformation that maps shape S onto shape T. So just make sure you know which way round you're doing it though. Which shape is onto which shape, because I feel like naturally you want to look at T to S, just because of the order that it's drawn in, but actually they have said S to T. That's the first thing. We've got 2 marks, so we want a single transformation and then one piece of information about that transformation. So which transformation is it? We're going to have either reflection, rotation, enlargement, or translation. That's the first thing. here, it's obviously not a rotation because they're both, like, the shapes are still the same way up, aren't they? It's not a reflection either because of the same reason. They're both, do you know what I mean? They're both facing the same way. It's like this bit is still the same direction. It's not being flipped. It's not being rotated. So it's not either of those. Enlargement, it's not an enlargement because obviously it hasn't changed size, has it, either? So the last thing that we could say is it's a translation. That's the one where it's just been moved left, right, up and down. So the first mark is for what type of transformation. And then the second mark is for information about the translation itself. So that's obviously like actually the numbers, isn't it? How many has it moved by? So pick a corner, might pick this one, and then obviously same corner on the other shape. And then how many have I moved left and right? 1, 2, 3, 4, 5. Left. And then how many up? 1, 2, 3, 4, 5, 6. So we put this in a column vector. Because we moved left, we've had to do -5 on the top number, and then because we've gone up, that is +6 on the bottom number. So that's our two pieces of information, the 2 marks. Question 3, we've got the length of a football pitch is 90 meters, correct to the nearest meter. Complete the error interval for the length of the football pitch. So error interval is effectively the same as upper and lower bounds when it's rounded. So they've rounded it to the nearest meter, haven't they? So that could have been rounded up, it could have been rounded down. So we just want whatever they've rounded it to, which is 1 meter, nearest meter is 1 meter, isn't it? Half of that below, half of that above. So obviously half of a meter, 0.5. So that'd be 89.5. Because if you got that, you'd round it up to 90, wouldn't you? And then the upper one is 90.5. Now I know that technically you would round 90.5 up to 91 technically, but that's why the symbols, the inequality symbols are like this. The bottom one is equal to, could be equal to 89.5 or anything bigger. The top one is anything less than 90.5. Not equal. So that's fine as it is. Okay, question 4. Sorry everyone, I'm just pausing because the sound in the background is so loud. I don't know if it's affecting the sound here as well. I'm assuming it is. If the banging is really bad, let me know and I can see if we can just reschedule it to another time because it's obviously quite distracting. If it's fine, then we'll keep going. Okay, Festival A will be in a rectangular field with an area of 80,000 meters squared. The greatest number of people allowed to attend Festival A is 425. Festival B will be in a rectangular field 700 meters by 2,000 meters. The greatest number of people allowed to attend Festival B is 6,750. The area per person allowed for Festival B is greater than the area per person allowed for Festival A, but how much greater is it? So Festival A, we already know the area, 80,000. And they said the area per person, the word per is like a divide, isn't it? So divide that by the 425 people. Obviously, this one you'll want your calculator for. So 80,000 divided by 425. Now, that's not a great number, but just write down a few decimals. 188.235, maybe write down that many. Just for now, and we'll come back to it. Oh, 235. So that's the area per person, basically, isn't it? For A. This is A. So B, though, we do actually need to do a bit more, because you see how they haven't told us the area, they've just given us the dimensions. So we'd actually have to work out the area first, which, because it's a rectangle, obviously you just multiply both sides together, both dimensions. So you can work that out yourself, or you can obviously type it into the calculator to double check. Just make sure you have enough zeros. So we've got here 700 by 2000, yep. So you've got 14 and then 5 zeros you should have. 5 zeros, 1, 2, 3, 4, 5. Make sure you get that right. So that's 1,400,000 meters squared. And then do the same thing. So we know the area is now that 5 zeros divided by how many people? 6,750. So take your answer, divide that by 6,750. And again, just write down maybe 3 decimals or so. 207.407. That's the same thing, meters squared per person for B. Okay, they've obviously already said that the area per person for Festival B is bigger, greater, so we can see that. That works with my working out. But they've said how much greater. So the last thing I need to do is then actually subtract that to find like a difference. So 207, you can obviously just copy your answer from your calculator when we do this last bit, minus 188 basically. 207 minus 188.235, or as many decimals as you wrote down, is 19.17. Now just double check. They want it to the nearest whole number, so it should round to 19. Okay, as long as you've got 19, then you'll be fine. Okay, that's part A. Part B, Callum says 300 centimeters squared is the same as 3 meters squared because there are 100 centimeters in 1 meter. So you just divide by 100. Callum's method is wrong. We need to explain why. So this is completely separate to part A. This is a different question. When they say what's wrong, you can almost just correct them, say what it should be. Sometimes I find that's easier to say what is correct rather than explain why something's wrong. So if you know the conversion, which actually is something that I would probably recommend memorizing because this does come up, the conversion between meter squared and centimeter squared, I would just write, because this 1 meter squared is the same as however many centimeters squared. That's a good way to put it. So 1 meter squared is, the way that I would explain it, if you're not sure why, is you would obviously do, so that's a square, that's 1 meter, 1 meter. That's 1 meter times 1 meter, isn't it? Now, the thing that you have to convert, yeah, there are 100 centimeters in a meter, but you see how you've done that, not twice, but you've multiplied it by itself. So if I had the same square, where that was 1 meter, this would be 100 centimeters, wouldn't it? This would be 100 centimeters. So your actual area would be 100 centimeters times 100 centimeters, which is obviously not 100 centimeters as an answer, is it? It's not 100 centimeters squared, it's 10,000 centimeters squared. So what you can say is, for example, 1 meter is 100 centimeters, so therefore 1 meter squared is 10,000 centimeters squared. That would be enough. They've said, just for a few options, you could also say what's wrong with it is that it's area, not length. They've even allowed that, which I feel like is very vague. But these worded questions, they're not looking for a really over-explained answer. It's literally 1 mark. So you could have said that as well. So 1 meter squared is actually 10,000 centimeters squared, or it's area, not length. So we're talking about 2 dimensions, not 1 dimension. Obviously, this conversion here is for a length, isn't it? For 1 dimension, not 2. So any of kind of those answers would be fine. Question 5, the points L, M, and N are such that L, M, N is a straight line. The coordinates of L are -3, 1. The coordinates of M are 4, 9. Given that L, M, and N, N is 2 to 3, we need to find the coordinates of N. Okay. So I'm going to draw a straight line. You can draw it kind of accurately to the coordinates if you want, or you can just literally draw a straight line. It doesn't really matter. I like to visualize it myself. So I just draw a quick sketch of some axes. -3, 1 is, roughly here. That's L. M is then 4, 9. So let's say here. And then N is therefore kind of somewhere over here, basically, isn't it? Because that would create a straight line. Just so you can visualize it, you can do that if that's helpful. Let me get my straight line. Okay, well, let's obviously imagine that M is on that line. Okay, so find the coordinates of N. So what I would do, I know that it's like a diagonal line. I don't think I would use Pythagoras though. I think that would just be too complicated. I'm sure you could do that, but I don't think I would. What I would probably do is just work out horizontally and vertically, just those two measurements, rather than just a diagonal. So what I mean by that is obviously this one, L was at -3, wasn't it? And then M was at 4. Do you see how that distance there is 7, isn't it? The distance between them horizontally is 7. And then do the same vertically. So L was at, what was it, at 1, I think. Yeah, 1. And M was at 9. So that vertical distance, no, it's not obviously to scale, is 8. And then I would just use that in the ratio to work out, therefore, what would be my horizontal distance here to get from M to N, and then also vertically. I would do that. Okay, so what I mean by that is now we need to look at the ratio. They've said that L to M is like 2 parts, and then M to N is 3 parts. Obviously, that's a little bit bigger, isn't it, M to N? So 2 to 3. Now, if we're just looking at the horizontal or the x-axis, let's say that, x-axis, do you see how we've got 7, as in the distance is 7? It's basically just working out a ratio. When I've been given one side, how do I find the other? Well, you just say, well, how do I go from 2 to 7? Or divide it by, divide 7 by 2, which is 7 over 2, or 3.5. And then you times it by 3. So you do 7 divided by 2, and then you times it by the number of parts on the other side, which gives you 10.5. If you've got it as a fraction, that's also fine, whatever format you get. So what that means is that from M to N horizontally, I need to add another 10.5. So from M, which you see how the x coordinate is 4, I need to add another 10.5. So the coordinate's not 10.5, it's the distance, isn't it? So I need to add another 10.5, which would give me, obviously, 4 plus 10.5, which is 14.5. So that's the x, okay? I'm just doing them separately, x and y separate. That's the x. I don't know why the space is so small there. And then you can do y. So y, we said vertically, the difference or the distance is 8. Do the same thing, so 8 divided by 2, which is 4, then times it by 3 on the other side, gives me 12. So that distance vertically, this distance here, is 12. But do you see how I'm starting at 9? I'm not starting from 0, I'm starting at 9. So that would be 9 plus 12. So you should get 21. That's what I would do. Do you see how I'm not using Pythagoras? I'm not kind of worrying about a diagonal because I think that's quite complicated. I'm just going to split it into x-axis, y-axis, horizontal and vertical measurements. Okay, question 6. This one's a really nice one if you can recognize what topic it is. It doesn't really say in the question, but as long as you can pick it up. So we've got a new phone cost £679. The value of the phone decreases at a rate of 4% per year. Work out the value of the phone at the end of 3 years. So we've been given a starting value, like a principal or an initial value. We've been given a rate, a percentage rate per year. And we've been given a time frame, so years, 3 years. This is compounding. Now, it's not literally compound interest, because interest is a different context, isn't it? Interest is when you're increasing money. This is just compounding, or sometimes they call it depreciation. I don't know if you've seen that, depreciation. Basically a decreasing value, but it's the exact same formula as compound interest. The only thing you need to do is, obviously it says decrease. So you need to do, instead of plus, we need to subtract. So I think on your formula sheet, you do get the formula for compound interest. We can use that and just apply it to this context. So you would do your, I think they call it principal amount or your initial amount, whatever your starting amount is, right? Multiplied by 1. Now, compound interest is plus here. But because we're decreasing, we're losing money, it's going to be minus, okay? So I know on your formula sheet it says plus, that's because it's just for compound interest. In the context of decreasing, you do minus. Then obviously you do your rate, your percentage over 100 to convert it into a decimal to the number of years or the time or whatever time frame you've got. So it's exactly the same formula that's on your formula sheet, just change it for a negative. So you don't have to go through, obviously you can go through and work out year 1, year 2, year 3, but you don't have to. So initial amount, £679, times by 1 minus 4 over 100, which in other words is 0.96, isn't it? You could also put 0.96 directly if you wanted to the power of 3. As long as you type in one of these two equations, you'll get the same answer. So 679, I normally do the 0.96 one because I normally work out the percentage myself, but it doesn't matter which you use. Same thing. 600, and it hasn't told you how to round it, but because it's money, I would probably just round it to 2 decimal places. 674. £600, 74 pence. Okay, so that's super straightforward. You don't need to write all of this, just write one of these two. If you can recognize that it's those 3 things, some kind of initial amount, some kind of rate, some kind of time frame, is normally some form of compounding, whether that's increasing, which is interest, or decreasing, because it's value, it's losing value, doesn't matter. It's the same concept. So that's a really nice one. Okay, question 7, we've got some conversions here. In Spain, Sam pays €27 for 18 litres of petrol. In Wales, Leo pays £40.80 for 8 gallons of the same type of petrol. Obviously, they've given you the conversions, right? You don't need to memorize, like, the exchange rates at this point. They'll give it to you, okay? And also litres to gallons, because we've got metric and imperial, they'll give you that. So you don't need to know any of those. Sam thinks that petrol is cheaper in Spain than in Wales. Is Sam correct? So we just need to work it out. This is live, just so you know. I think the actual video is about 30 seconds behind when I'm literally saying it, but beyond that, this is live, yeah. That's why the audio at the start was quite bad. Okay, so there's loads of different ways to do this. You just have to make sure that you can convert them both into the same currency and them both into the same either litres or gallons. It doesn't matter which you choose, as long as you convert them both, so then you can compare them at the end. So what I chose to do was I chose to convert the euros into pounds, first of all. So we had €1 is 85p basically. And then you see how I've been given €27. So how many pounds is that? For conversions, when you've been given, let's say in this case, the currency. When I say base currency, I mean the one that they used as 1. So you see how this is €1. So they based it in euros, haven't they? When your currency, so in this case the €27, is the same as that, all you need to do is multiply by, obviously, the pounds. Sometimes you multiply, sometimes you divide. It just depends on yeah, if your base currency is the same one that you're converting from or if they're different. Multiplying, I think, is always easier. So 27 times by 0.85. You can also think about it as, should I get fewer pounds? Like, should my answer in pounds be less than 27? Well, yeah, because we've got 85p as every euro, so we're going to have fewer pounds as an answer, aren't we? 22.95. Okay, so that's saying that in Spain, it's 22.95 in pounds for 18 litres, isn't it? So we've converted one. The other one was 40 pounds, 80. They're both in pounds. However, I can't compare it directly because see how the gallons and the litres is then the problem. So now I need to convert these two bits. Now, some people might just go, I'm just going to convert the Spain ones both. So convert the euros to pounds and convert the litres to gallons. I actually converted the gallons into litres. And the only reason why I did that is, again, because do you see how the conversion for litres and gallons, the base one is gallons, isn't it? 1 gallon. So I would just have to multiply again. That to some people might not make sense because I've kind of converted one of Spain and one of Wales. You might find that more confusing. I just preferred it because I then didn't have to divide anything. So we had 4.5 litres is the same as 1 gallon. So how much is 8 gallons? Again, you can see it's quite obvious I'd need to multiply by 4.5, wouldn't I? So 8 times, let me write that properly. 8 times 4.5. As long as you do any version of converting both of them, then it's fine. So 8 times 4.5, I'm pretty sure, gives you 36. Yep, 36 litres. And then that's for £40.80. So now we've got them both in pounds, both in litres, or whatever version you chose to do, as long as you've got them both in the same currency and in the same, litres or gallons, same measurement. The last thing is that they're not the same quantity, are they? So again, I can't really compare it straight away. What you can do is then work out, there's multiple options. Do you want to know how much 1 litre costs for Spain and therefore how much 1 litre costs for Wales? Or you could go, well, I know that 36 is double 18. You could just double this one and compare those. Again, there's loads of different options as to how you can do it. The way that I just naturally went and did it was I just did 1 litre for each. How much does 1 litre cost? So for example, Spain is £22.95 for 18 litres. So obviously if I divide 22.95 by 18 litres, that will tell me how much 1 litre costs in pounds. So in Spain it costs £1.27, technically 0.5. 1, 2, I'm going to put all the decimals just for detail. So that's per litre, isn't it? And then Wales, to find out how much it costs for 1 litre, £40.80 divided by 36 litres. Gives me £1.13 effectively. So Sam thinks that petrol is cheaper in Spain than it is in Wales. Well, the way that I've done it, I can have a look. Is it cheaper in Spain? Well, no. It's not, is it? It costs more in Spain. So is Sam correct? You'd have to put a conclusion. You don't have to explain it. Just be like, therefore no. Because that's clear enough, isn't it? He's not correct. So the conversion one, there's just loads of different ways to do it. It just depends what you prefer to do, basically. Okay, question 8. So this is a nice one. Just use your calculator to work out all of this and give your answer correct to 3 significant figures. So obviously I'm going to type in my calculator. The only thing that I did notice in the mark scheme for this, which I hadn't realised, you can see it's 2 marks, is that one of the marks, as in one of the method marks, was for writing down like a halfway point. Now, I would have just typed this all in and then put the answer straight away. That's what I would have naturally done. So I think what I would do to get the method mark is maybe work out either the top or the bottom and write that down as a number. It seems kind of stupid to do that, but I just saw it on the mark scheme that they were looking for a method mark there. So maybe if we just do the numerator, tan 60, like maybe if you write down that, what was it, 1.98385, something like that, 1.9838 over, and then maybe if you work out the other part, you know, it's kind of annoying, but might as well get all the marks. 2.68328. Like maybe if you write down something like that, and then obviously put your answer. So let's go back. Plus tan 60 over, I'm just going to put answer because obviously that was my previous answer, wasn't it? So this is the actual answer. Now they have actually said correct 3 significant figures, so that would be 0.739, and then it wouldn't round, would it? It would round down. That would be your actual answer. They have said as long as you get between this and 0.747, they'll accept it. So there is a slight range for some reason. And I think they still give it to you even if you don't round it correctly, which is odd because that is the question, isn't it? But I think they would give it to you if you didn't round it correctly. But obviously, make sure that you try to fully answer the question. Question 9. A box in the shape of a cuboid is placed on a horizontal floor. The box exerts a force of 180 newtons on the floor. The box exerts a pressure of 187.5 newtons per square meter on the floor. The face in contact with the floor is a rectangle of length 1.2 meters with width x meters. Work out the value of x, and they've obviously given us the formula. So for pressure, you don't need to know the formula, they will give it to you. The one you do need to know is density. That one they don't give to you, so that one you do need to memorize. That's obviously not relevant to this question. So here, we can use this formula, pressure, force, area. They've given us force and pressure, haven't they? I normally do a little formula triangle. You can obviously just rearrange that if you want. So pressure, force is always at the top, area. We've got force and pressure, so the only thing we can work out is then area. So area of obviously the face that is in contact with the floor, that's what the area represents, is the force, 180, divided by the pressure, which is 187. I didn't need to change this because the units were already matching up, weren't they? See how that's newtons and then newtons per meter squared, so I didn't need to worry about anything. Obviously, I'm going to divide that. 180 divided by 187.5 gives me 0.96. Now that's meters squared, because you see how the pressure was in terms of meters squared. So that's the first bit. We found the area. Now we can look at this next sentence where they said that the floor is a rectangle, the length is 1.2 meters, the width is x. So the area of a rectangle, you would do the length, which is 1.2, times the width, wouldn't you, which is x. So you see how I can create this equation? Now all I need to do is divide by the length. So take my answer, divide it by 1.2, and I get 0.8. So x, 0.8. Now they've said x is in terms of meters, so the units again are all correct. We don't need to convert anything, just double check that in case you need to convert it. X is 0.8. That's it. Okay, question 10, we've got some box plots. So the box plot shows information about the sales in thousands of pounds of an online store each month. So this one's online, okay? Andrew says 3/4 of the given data lies between 160,000 and 350,000 because these are the values of the lower quartile and the upper quartile. So the lower quartile is always the left-hand side of the box, isn't it? And the upper quartile is always the right-hand side. Andrew is wrong. Explain why. Well, I'd say he has read it off correctly. That is the upper and the lower quartile, isn't it? That is correct, 160 and 350. However, the bit that's incorrect is the 3/4. Because we should know what the lower quartile and upper quartile represent. The lower quartile is 25% of the data. The upper quartile is 75% of the data. So they've said lies between the upper and lower quartile. Well, that's the interquartile range, isn't it? Now the range is therefore between this bit, which is therefore between 25 and 75%. Well, that would be 50%, wouldn't it? That's not 75%, that's not 3/4. So that's why Andrew is wrong. So again, you can almost just correct him. You say what it should be. So you could say half or 50% of the data lies between the upper and lower quartile. Any version of that, you say the interquartile range is the middle 50%, or the 3/4 also technically would include this left-hand side, wouldn't it? From 0. Any version of that, any kind of explanation that roughly says the same thing is fine. Okay, part B, the table shows information about the sales in thousands of pounds in a shop. So the reason why I highlighted online. The other one was an online store. This is now a shop. Kind of sounds the same, but obviously that's the difference. This is like a physical shop. So they've given us the least, lower quartile, median, upper quartile, and greatest. On the grid below, draw a box plot for this information. So that is all of the 5 pieces of information we need, isn't it? So that's perfect. You can just go straight in and draw all of these. So the least value is at 30. Make sure you check what the scale is. This one's quite an easy scale, which is good. So 30 there. Lower quartiles at 80. Then median 170. These are really easy marks, obviously, as long as you get all of the points in the correct place. Okay, upper quartile 260, which is here. Obviously, you'll be able to draw a lot more easily with your ruler and pencil in real life. And then the greatest value is 350. Okay. Then you join up, obviously, the 3 in the middle to create that box. You're effectively replicating the box that they had at the top, aren't you? In part A. And then the other 2 are just kind of like these little whiskers or kind of tail parts, aren't they? Something like that. Yours will hopefully be a lot better than mine because you can do it with an actual ruler and a pencil. Okay, 2 marks. And I think there is a part C. Yep, part C. So compare the distribution of the sales of the online store with the distribution of the sales in the shop. They've given you a lot of lines here, but it's 2 marks. This is actually a really nice question, just because it's always the same answer. So as long as you memorize what you need to mention, then you can get the answer. So when they say compare the distribution between 2 box plots, they want you to mention 2 things. The first thing is the median. That's probably fairly obvious because it's one of the main measurements, isn't it? So you mention the median. Get my pen back. So number 1, so for your first mark, is the median. What you need to do though is they say compare. You don't have to explain anything. It's not like that complicated. You just have to literally compare them. So the median, for example, like the median of this one is bigger than the median of that one. The median of that one is smaller than, literally make a comparison. So let's go back. The median here, they said was 170 of the shop. We come back up, 170. The median of the online store, this is this one here, isn't it? Which is 200. So we've got 170 and 200. So the online store has a higher median. So you could say the median, relate it to the context, right? Median sales of the online store was greater or higher or bigger or, whatever you want to say, than the median sales, and then you just say the other one, of the shop. Now, in the mark scheme, it says you don't necessarily have to put figures. So you know how we said the 200 and the 170. It says you don't have to put figures, but if you do put them, you have to make sure they are correct. So if you put figures but you get them wrong, you could lose the mark. So that's up to you. I thought you had to put figures, so I normally do. But I did check the mark scheme, and I've seen it a couple of times. It says you don't have to put the figures, but if you do put numbers, they have to be correct. So that's up to you whether you want to risk that. Okay, that's the first thing. The second thing is then a measure of spread, which is either the range as a whole, they'll accept, or the interquartile range. Now, I tend to use interquartile range because that one's a bit more specific, but as long as you do some kind of range, and that's what, again, we're going to compare it. So we come back, the interquartile range of this one, he said, was 350 and 160. So the interquartile range, 350 minus 160 would be 190 for the online store. That's the interquartile range, 190,000. Here, we've got lower quartile was 80, wasn't it? They said 80, and the upper quartile was 260, which I think gives you, obviously interquartile range, you subtract them, don't you? Which gives you 180. So 190 and 180. That's very similar, isn't it? But technically, the online store is bigger. They are quite similar, but the online store is bigger. So you can say the interquartile range, again, just copy kind of the same thing of the context of sales of the online store. This is why there's loads of lines. It's just because you have to kind of add all these words in. Was also greater, or higher, or bigger. You know, any synonym of that is fine. The interquartile range of sales of the shop. Just as long as you relate it to the context of the question. That's fine. That's your 2 marks. As long as you mention those 2 things, it's the same every time. And obviously making comparisons is quite an easy thing to do. Ooh. Okay. Question 11. This is one where, again, hopefully I'd want you to kind of learn to recognize what topic this is, and then it's a little bit easier. So Kieran has 13 workers he can use for a job. He knows that 6 workers would take 14.5 days to complete this job. Show that Kieran has enough workers to finish the job in less than 7 days. This is like inverse proportion. I know it doesn't mention it, but the concept is inverse proportion, because the more workers you have, the less time it will take. Or the fewer workers you have, the more time it will take. It's the opposite, isn't it? So this one, I feel like you naturally want to work out how long it takes for 1 worker to complete the job, but I feel like naturally you want to do 14.5 divided by 6 to get 1 worker, but it's inverse proportion, so that doesn't work. You have to multiply it. If I only had 1 worker to complete the same job, it's going to take 6 times as long, isn't it? It's going to take longer. So that's just the only thing to bear in mind there. It's the opposite calculation to what you might naturally think. So if I had 1 worker, it would take them 87 days. Now, he obviously didn't have 1 worker. You then apply it to how many he has. He actually has 13. So 13 workers, how long would that take? Now, this is the one where you kind of want to do 87 divided by 13. So it takes 1 worker 87 days. 13 workers will be less time. 13 days, 13 times faster. So you do 87 divided by 13. And we're obviously hoping that's going to be less than 7, isn't it? That's what they've asked us to show. 6.69 ... days. Which is, they said show it's less than 7, I would probably just write a little inequality to conclude it. That's obviously less than 7, isn't it? 3 marks. Okay, so you normally, when you get a question like this, and it could be workers, painters, builders, that kind of thing, or it could be, I've seen in the context of taps, filling a swimming pool. How long does it take for 5 taps to fill a swimming pool? If it takes 3 taps, 10 hours, or whatever. That's the kind of context. You first of all multiply the 2 numbers together that they give you, because this is like a pair, isn't it? And then you divide by the actual number they have and that they want to calculate. So that one's quite nice if you can recognize what it is. Question 12. The equation of the line 1 is y equals 2x plus 3. The equation of line 2 is 5y minus 10x plus 4 is equal to 0. Show that these two lines are parallel. Make sure you recognize that they have to be parallel, because a lot of the time in higher tier they go with perpendicular, don't they? So just obviously make sure you read it properly. It is parallel this time. When they're parallel, it means that they have the same gradient. And the gradient of a straight line, if you write it in the context of y being the subject, is m, the coefficient of x. So what we need to do is compare the coefficients of both lines of x, and if they're the same number, it means they're parallel. Now, you can't just compare minus 10 and 2 though, because you see how the second one is not in the same, like it's not rearranged in the same way. So we can't compare, the gradient of the second line is not minus 10. You need to rearrange them so that y is the subject. Obviously the first one was already fine, so we don't need to do that. But the second one, let's write this down. The second one I'm going to rearrange first to get y as my subject. So first I would have to add 10x and take away 4, and then I'd have to divide by 5. Divide both of them separately. So 10 divided by 5 is obviously 2, and then just put this as 4 over 5. So that's line 2, isn't it? And now we can compare the gradients, the coefficient of x. They both have not only 2, but it has to be the same symbol as well. They're both positive 2x, aren't they? So they both have the gradient of 2. I would probably put as a conclusion something like line 1 and line 2 have the same gradient. In brackets, you could put the actual gradient, which is 2. Therefore, they are parallel. If you can spell parallel, that's meant to be an E. Therefore, they're parallel. That's probably what I would put. Just rearrange the first one and then some way to identify that you've compared the gradients, the coefficients of x. That's it for that one, 2 marks. Question 13, we've been asked to enlarge the shaded shape by the scale factor -2 with the centre of enlargement 0, 0. So mark your centre of enlargement first. 0, 0. Now, higher tier, when they ask you to enlarge a shape, a lot of the time it is a negative scale factor, isn't it? That's quite common. So obviously, not only is the shape going to be twice as big and twice as far away from the centre of enlargement, but the negative means that it inverts itself. So, and you can kind of tell that because technically if it was to get only bigger by 2, it'd probably be somewhere over here, wouldn't it? But there's no space for that. So it's not going to be over here. It's not just a normal enlargement by 2. The way that I do it, some people like to draw the lines. I personally don't like to do that. That's just me. Is I pick one corner to start with. Let's say this one. And I count the squares as in vertically, horizontally. Start from your centre of enlargement. Don't start from the shape. Okay, so from the centre of enlargement, do you see how I need to go 1, 2, 3 to the left and then 1, 2 down to get to that corner? I'm going to take those 2 measurements. Obviously, I'm going to times them both by 2 because it needs to be twice as big. But the negative means invert it, as in, do you see how that went 3 to the left? I now, instead of going left and down, I now need to go right and up. That's the complete opposite, isn't it? So instead of 3 left, I need to go 6 right. So again, from the center, so that's 6 here. Instead of going 2 down, I need to go 4 up. So that corner is now here. And then I just go through, and either you can obviously do the same with all 4 corners, or you can just plot from the corner you've already plotted. So for example, if I get a different color, this one. From my pink corner, that one was 2 to the left. So from my pink corner over here, it's going to be not 2 but 4, but also not left but right. So 4 across here. And then you see how I can start building it from there. That's what I like to do. It's a personal preference again. It's all up to you. Let's get a different color. So this corner, I'm probably going to just go from the centre of enlargement for this one, was 2 left, 4 down. So that's 4 right and 8 up. Okay, and then the last one you can kind of see where it's going to be, can't you? You can probably figure that one out. That one needs to be there. Okay, and obviously then you need to join it up. Sometimes they ask you to label it. In this case they haven't, so that's it. But you see how not only is it naturally twice as big and also inverted, it's also, look at that distance. It's twice as far away from the enlargement, the center of enlargement. So it's not just about the size of it, it's about the location as well. So up to you whether you want to use the lines where you cross through or if you want to count like I like to count. Okay, question 14. Saffron wants to work out an estimate for the total number of fish in a lake. This is, just by looking at it initially, is a topic called capture recapture, which I feel like is such a small topic. I don't know if you remember it or not. I don't remember it when I was at school. Capture recapture. Doesn't always come up, but it's really easy if you memorize the formula. You just apply the formula. So yeah, as long as you memorize the formula, then you're okay. So she wants to work out an estimate for the total number of fish in a lake. On Friday, Saffron catches 180 fish from the lake. She puts a tag on each of these fish and puts them back into the lake. And then on Saturday, Saffron catches 305 fish from the lake. She finds that 45 of the 305 fish are tagged. Work out an estimate for the total number of fish in the lake. So it could be fish, it could be kind of any animal. It's normally an animal, obviously, but any kind of fish or animal. And sometimes they tag them, sometimes they say they mark them, but it's all the same topic. So we need to know the formula, and all you need to do then is sub it into the formula. So to find your, this is kind of like estimated total number, isn't it? I'll just write down the formula so you can have it. Estimated total. What you want to do is the number that are tagged, or as I said, sometimes they're marked. You get the gist. So that's the number from the first day, basically, multiplied by the total that she recaptures, whether they're tagged or not. And then you divide that by the number that were tagged and recaptured when recaptured. However you want to word it, you can obviously change the wording. So there's three numbers, you basically just have to multiply 2 and then divide by the third number. So multiply the number tagged, which is 180, right? That's the number on the first day that was captured, by the total that she recaptured, which is 305, and then divide that by how many were tagged out of the recaptured, which was 45. That's literally all you need to do for this question. So if it doesn't always come up, but if it does, it's really nice if you can memorize this formula. That's the only thing. It's just another formula to memorize. There you go. Answer 1220. Obviously, you don't need to write down the formula itself. I've just written that down for you guys. But this is the working, and then that's your answer. Really straightforward if you know what to do with the formula. Okay, question 15. This one is less straightforward, I would say. So the ratio of Marta's hourly pay to Khalid's hourly pay is 6:5. Both Marta and Khalid get an increase of £1.50 in their hourly pay. The ratio of Marta's hourly pay to Khalid's hourly pay after this increase is 13:11. Work out the hourly pay before the increase for Marta and for Khalid. So this one actually has a few different ways to do it again. So the way that I might do it, you might do it differently. As long as obviously we get the same answer, then it's fine. Yeah, there are multiple different ways to do this. I created an equation, and I've mentioned this in a couple of the other exams that we've been through. It's come up a few times, how to convert a ratio into an equation. You can do it that way. You can use that link. I think that's probably more complicated actually, now that I look at it. The other way, actually, I might show you another way. The other way I did it was, at first I kind of thought, well, if I double this, do you see how, so we have 6:5. If I double it, it's the same ratio, isn't it? It's just a bigger scale. And then I compared it to 13 to 11. Do you see how both of them have got one part extra on both sides? Both have got one part extra. And it said that Marta and Khalid both get the same increase of £1.50. So what you can do is go, oh, well, therefore one part of the second one, or of this, at least the doubled version, right? One part is the same, is equivalent to 150. That's probably more straightforward than doing equations, but you can do equations. Therefore, they actually wanted to know what was the hourly pay of both of them before. Now, it's not just 1 times 6, right? Because the one part is in relation to the doubled version. That's the only thing you've got to consider. So you would want to use this ratio here, the new one, the 12 to 10. So what was it? Marta was first. Marta would be 12 times 150, which I think gives you 18. And then Khalid would be 10 times 150, which is obviously 15. That's probably the most straightforward way to do it. But you might have used equations, and there's a couple of different ways to use the equations as well. You might have used equations for it as well. As long as you've got 18 and 15, then that's fine. The only thing here is just making sure that once you've worked out that one part is 150, that you don't use the wrong ratio, that you use the ratio that was the correct scale, the 12 to 10. That's the only kind of risk with that one. So yeah, a bit of an odd one, that one. Okay, question 16, we've got a nice Venn diagrams one. A shop manager wants to advertise special offers on social media platforms. The manager asks 100 customers which of type A, type B, or type C they use. So, of these customers, we then get obviously a list of information. We need to use all of this to complete the Venn diagram, which is 4 marks. So I'm going to go through the list of information and tick it off as I use it. So 4, use all 3 types. Now we can always put that straight in the middle. That one's fine to just put straight away. 16, do not use any of type A, type B, or type C. So that's obviously on the outside, isn't it? That can also go straight in. Then it says 8, use both type A and type B, but not, specifically not type C. So that tells me that this top bit here, this bit here, is 8, because it doesn't include C, which is the middle part. So that's 8. So this is a bit where you have to start being a bit careful. That one is 8. However, you'll see what I mean when we look at this next line. So get rid of that. Do you see how this one then says 14 use both type B and type C? So you kind of think, sometimes you just think, oh yeah, that's 14. But they haven't specified that it's not including A, have they? They haven't specified that. So you have to really you just have to be really careful, really make sure on these questions. Have they specified this one, and not the third one? So when it says 14 use type B and type C, that could still include A. So that is actually all of this. That's all of this is 14. Okay, so you have to do, in that case, 14 minus the 4 that's already in the middle. So therefore, this bit here is actually 10. So that's where you have to start kind of making some calculations and stuff. Okay, 62 in total use type A. So that's the whole bubble. The only thing is I need to pause on that because there's 2 sections I don't know. So I'm going to pause on that one and then look at the last bit. All 20 who use type C, so the whole bubble of C is 20, also use at least one of type A and B. So that means there's nothing in only C. And so that means also that this bit, these 3 sections, must equal 20. Okay, so that's 14 together, and then in total 20, so that's 6, isn't it? So again, you have to do the calculation. Now I can come back and look at the 62 for A. The whole bubble for A is 62, so I need to take away the rest. So 62 minus 8 minus 4 minus 6. So that is 44. Now, you've used all the information, but double check that you've actually filled in everything in the Venn diagram. Do you see how the B on its own is missing a number? Now, that's not necessarily 0. What we have to do is then go back and say, well, they say there's 100 in total, so the whole Venn diagram should add up to 100. So we need to check, is there anything missing? So we've got 100 minus, A is 62 as a whole, isn't it? Minus 10 minus 16. 12. So there's actually 12 that we didn't account for that goes in B. So just double check. Is there one, the last one that's empty, is it 0 or is it actually a number of what's left? Obviously it shouldn't add up to more than 100. Okay, now we can use this Venn diagram. So one of the customers is chosen at random. Given that this customer uses type A, so given that it's already someone from type A bubble, let's have a look. Find the probability that this customer also uses type B. So what we're saying is we're isolating just the A bubble. So given that they're already from A, so that was, they said 62 people, wasn't it? See how that would be, your denominator would be 62 and not the whole 100? Because we're saying given that they're already from A, what is the probability that they are also type B? So if I get different colour, that would be this here, wouldn't it? They've not said they can't be type C either, so that would include the middle. Do you see how that would add up to 12? So your answer for 2 marks is 12 out of 62. You can obviously half that and get 6 out of 31, but probability you don't tend to need to actually simplify it, just leave it as it is. Okay, so it's not out of 100 because they said given that this person already is from type A. So given that they're out of 62 people in type A, how many also use type B? Okay, question 17. A solid cone is joined to a solid hemisphere to make the solid T shown below. So that whole thing, this whole thing here is T. The diameter of the base of the cone is 7, and the diameter of the hemisphere is also 7, as you can see. The total volume of T is 120 pi centimeters cubed, and the total height of the T shape is Y. We need to calculate the value of Y, and they've obviously given us formulas because these aren't prisms. So what I would do is I would create a whole equation, because they've told us the volume of the whole shape, and then they've given us the formulas for the volumes of those shapes separately. So you'd obviously work out the volume of the cone, then you would add it to the volume of the hemisphere. So the cone is 1/3 pi. Now the radius, not 7, they've done that deliberately, the diameter is 7. The radius is obviously either 3.5 you can write down, I would probably just leave it as a fraction, 7/2. The radius is half of that, isn't it? So that's squared and then times by the height. Now the height is not Y though, because we just want the height of the cone. So the way that I would write down the height of the cone is, see how this pink bit, it's not straight, but that pink bit comes from the center of the hemisphere to the outside. Technically, that's the radius of the hemisphere, isn't it? That pink bit. So we know that the radius is half of 7, so that's 7/2, or as we said, 3.5. So the height of just the cone, you could write it as Y minus 7/2 or minus 3.5. But just be careful, because Y is not the height of the cone only. It's the height of all of it. So that's the volume of the cone plus the volume of the hemisphere. Now, the other thing as well is that they will only ever give you the volume of a sphere. It's the whole thing. This is obviously half. So we've got obviously the formula for the sphere, which is pi, 4/3 pi, radius again, 7/2, cubed, but we need to remember to divide that by 2 because it's only half of the whole sphere. And then that is what equals to 120 pi. So it's a little bit complex, but I've got a whole equation here. Do you see how the only thing that I don't know, as in the only letter, is Y, which is good because I only want to find Y. Now all we need to do is just try and simplify and rearrange and solve this equation for Y. The first thing I thought to do was, you see how each of these 3 terms have pi in it? So if you were to divide the whole equation by pi, they would all cancel. So we can get rid of those immediately. Then the fractions we can work out. So see how here we've got, for the first one, you've got 1/3 multiplied by 7/2 squared. Don't forget to square it. Which obviously I would probably leave it as a fraction, right? Because that decimal's not nice. 49/12 and then you've still got your y minus 7 over 2. Then I would do the same here. So we've got 4/3 multiplied by 7 over 2. Now this one is cubed though, so make sure you get that right as well. Cubed, I think I need to put there. And then that was the whole circle, well, the whole sphere, wasn't it? So I need to divide that by 2. Again, I would leave that just as a fraction. 343 over 12. Luckily, it's got the same denominator. And then this is just 120, isn't it? So we're getting there slowly. So I'd probably subtract this one across, I think. So 120 minus my answer, 1097 over 12. They're not nice numbers. It doesn't really inspire much confidence that you've got it right, to be honest. Normally the numbers are a bit nicer than this, but it's fine. So we've got this. Then I would probably divide by the 49 over 12. So divide that. Just use your answer button to copy it across by 49 over 12, which is 1097 over 49. And we're almost there. Obviously, I would just add 7 over 2, or 3.5. Add 7 over 2. Now, this is then the bit where we can convert it into an actual number, because this is our final answer, isn't it? We've just worked out what y is. They have said 3 significant figures. So y is 25.8. That's 3 significant figures, but the next number is also an 8. So that would mean my first 8 would round up to 25.9. Again, I don't think they're fussy about the rounding, to be fair. But I would obviously try and get it right if you can. They have said anything between 25.8 and 26.3 they'll accept. But officially, 25.9 is the official answer. So that's just setting up an equation based on the context, and then just being confident that you can rearrange equations. That's basically what that is. Okay. Get rid of this thing. Okay, there's also a part B. So the diameter of the base of the cone and the diameter of the hemisphere are both increased by the same amount. Okay, so the diameter of both are increased. So if you imagine that shape T is now kind of like wider, isn't it? Assuming that the total volume of T does not change. Okay, so the volume is still the same, 120 pi. Explain the effect this would have on your answer to part A. So my answer was the height of the whole shape, wasn't it? Y represented the whole shape. So it's basically saying, how would the height of the shape change if it had a bigger diameter but the volume was the same? So imagine if the volume was the same, you're stretching it, the shape, horizontally, you're making it wider. Therefore, if you think about it, it would be shorter, wouldn't it? The height would, or the I would have written, the height would be less, because you have to relate it to your part A. Part A was the height, wasn't it? Or you could say the letter Y if you wanted. The height of T, which was the whole shape, would be less or would decrease, or, you know, some kind of, as long as you don't say increase, because that's obviously incorrect. As long as you kind of allude to the fact that it's decreasing or it's shorter or it's less or whatever it is, as long as you say something like that, then you'll get the answer. You'll get the mark. Okay, question 18. PQR and QRS are triangles. Calculate the length of QS. So that is this one over here. So we're getting towards the end of the paper. This is 4 marks. We've got some scalene triangles. We've got some angles. We've got some sides. This is immediately saying to me that therefore it's going to be sine or cosine rule or both. That's effectively, in my head, the process of elimination that I do. So at least I know what I'm roughly going into. Now, calculate this length of QS. In terms of the triangle QRS, we've got 2 angles. We've got a side that we want to calculate, but we don't have anything else. When you're using sine and cosine rule, for both of them, you need 4 pieces of information. Obviously, that includes the 1 piece of information that you're trying to find. In this case, we've only got 3. So that tells me, obviously, that in terms of the triangle QRS, I have something missing. I don't have enough information, hence why I need to look at triangle PQR. So what could I work out from PQR that would help me with QRS? Well, normally, that's the line between them, the line that they share, isn't it, the side. QR. So looking at the first triangle, you can always change the labels of the corners if it helps. I want to know this side here, QR. And I've been given the angle that's opposite and then two other sides. So you just have to figure out, does that slot into sine rule or cosine rule? Normally it will pretty much only slot into one of the two. Normally there's not, don't have the option of both, but if you have the option of both, just choose whichever you prefer. In this case, there's only one option. We have got three sides, including the one that I want to calculate, right? So three sides and one angle. That's cosine rule. Cosine rule is always three sides, one angle. Sine rule is two pairs, two sides, two angles. Okay, so this clearly would fit into cosine rule to start with. So cosine rule is obviously on your formula sheet. I'll write it here. We're looking for a side, so we can leave it in the same format that they've given it on the formula sheet, which is good. This is the cosine rule. It's based in terms of they've labelled the angle A. So I'm going to change this one to A just so I can match it up. This is therefore side A, because that's the one I'm trying to find. And then B and C are the sides that surround the angle, so it doesn't really matter which way around you put those. Now, all I need to do is just sub it into that. So QR squared is the same as 11 squared plus 9.4 squared. Obviously write it down and then type it into your calculator. 2 times 11 times 9.4 cos 27. Get your calculator. Now I've written it down like that, but I do tend to type it in differently, so I'll just show you. The first bit's fine, the first bit's the same. 9.4 squared. Then I do minus. Now this is the bit where I write it differently. I just put a big bracket on my calculator and then just do multiply like this. I don't write down all the different brackets. Obviously I don't write it down like this on my piece of paper because that doesn't really make sense in terms of algebra. Okay, close all the brackets, and we should get 25.0998 ... Now that's obviously squared though, isn't it? That's the QS squared. So you also have to square root it. So take your answer, don't round it too soon, just keep all of those decimals, square root, and that's what we get for QR. It's basically 5. I'm going to write down this. In my calculator, I'm going to keep the whole answer. I know that it's like 0.00 ... but I'm going to keep my whole answer in my calculator and then round it at the end, but technically it's effectively 5 centimeters roughly, isn't it, here? Now we're done with that one. We can now move on to the triangle we actually want to know about. So again, you go through and say, do I have the information that would fill in cosine rule or sine rule? So the information, I've got two sides, one that I know, one that I want, and then two angles. You see how that's more so sine rule? The only thing is then we have to make sure that they are opposite pairs. So what I mean by that is the 5 is opposite the angle 41, so that works as a pair. And then luckily the x is also opposite the other angle that I have. So yes, we have two pairs. So I can just directly use sine rule. I don't tend to label it because I feel like sine rule is a bit more obvious, but you obviously can if you want. So because we're looking for a side, that's what you're going to put at the top of the fraction. Sine rule works in the way that you just put the sides at the top if you want a side. If you want an angle, you put the angles at the top with the sine. So this is x, or you can obviously call it QS if you want. X over sine of the angle 88 has to be the one opposite, equals 5 over sine. Obviously the angles always go with sine or cosine. Now obviously sine and cosine rule you do have, well, sine rule particularly, in this case we have to rearrange it because I just want to get x. So you always multiply by whatever the denominator is. And that's actually what we'll type in to our calculator. Obviously remember now to use sine rule. Do you see how I've still got my previous answer? So I know I wrote down 5, but it's technically 5.0099. I've kept it in my calculator, so that now I'm going to use, instead of writing just 5, I'm going to copy my answer, just so that it's the most accurate I can get. It's over sine 41 multiplied by sine 88. Make sure obviously those are the right way around. Now this is my final answer, so I can round it now. They've said 3 significant figures again. So that would be 7.63. Now, again, they've given a slight range of possible answers, so as long as you got somewhere between 7.61 and 7.632 is what they've said. But that's the official answer, 7.63 is the exact answer. Okay, so that was just a quite straightforward sine and cosine rule question, actually. Okay, question 19. The functions g and h are such that g of x is the cube root of 2x minus 5 and h of x is 1 over x. First of all, find g of 16. This is just a normal function is what I'd call it, as in all I need to do is, you see how the difference, the only thing that's changed is that there used to be an x, now there's a 16. So what they're saying is when x is 16, you just sub in 16 to obviously the g function. So that's 2 times 16 instead of x minus 5. Now, you could actually work that out yourself, or you can put it in the calculator, it's up to you. It's not a decimal answer, so you can work it out manually if you want to. Minus 5, 3. Okay, that's probably the most simple, straightforward question. Obviously, it's only 1 mark for a reason. Okay. Part B, we need to find h of the inverse of g. You kind of have to interpret that. That is saying I need to do the inverse. If you were to put brackets in, it would be like this. Invert g and then sub it as a composite function into h. I've seen a past paper where they had hg and then they did this. Yeah, it was like that. Well, in that case, you would do the composite function. You do g into h, and then you would invert your answer. So you just have to be careful which one they're asking for. In this case, they're asking us to invert g and then sub it into h. Okay, so the inverse of g, well, what I normally do is put a y there. Now, some people they swap the x and the y now, and then they make y the subject again. I like to just make x the subject and then swap it at the end. So you either swap x and y now or at the end. It doesn't really matter. So I'm going to make x the subject. I obviously need to cube both sides. I obviously then need to add 5. And then my last step is to divide by 2. And obviously, I need to then rewrite it, officially. So the inverse function of g is, and then you swap the y for x. X cubed, oh, that's meant to be over 2, plus 5 over 2. If you can see all of that. Yeah. So that's the inverted version of g. Now I need to then sub that into h. So h was 1 over x. Wherever there's an x, I replace it with the whole of the inverse of g. So that would be x cubed plus 5 over 2. Now, obviously they want it in the simplest form. That's basically, when you do 1 over something, it's the reciprocal, isn't it? The reciprocal is another way of saying flip the fraction upside down. So effectively, that's the same as saying 2 over x cubed plus 5. It's just flipping that fraction. You can think of it as keep, flip, change, because you're dividing by a fraction, aren't you, if that works better. So your final answer should be that. 2x cubed plus 5. 2 over x cubed plus 5. That should be your final answer. So it was just a bit of both. It was an inverse function and it was composite after that. Okay, question 20. You can see we've obviously got some circle theorems now. I think we've got 3 more questions. So A, B, C, and D are points on the circumference of a circle, centre O, and they've said that A, D, E, and B, C, E are straight lines. They're not tangents, just so you don't get confused with that. They're not tangents, they're just straight lines. Work out the size of angles CDE. And obviously it says give a reason for each stage of your working. So first of all, which is CDE? CDE is this one. We've only got 2 things to work with, 132 and 16 degrees. Now, with circle theorems, there tends to be multiple different ways to find the answer. So the way that I might do it, you might have a different route. Again, as long as you get the same answer at the end, it should be fine. So my initial, my immediate thought was this 132 is almost screaming out to me to work out this one, isn't it? It's that arrow shape. Angle at the center is double the angle at the circumference. That one's really straightforward. So I'd write down BAD is technically 132 over 2. It's half of it, isn't it? The one at the circumference is smaller than the one at the center, which is 66 degrees. And then you could say that angle at center is double angle at circumference. That would be your reason, basically. Okay, so that's 66. And then what I thought is if you kind of mentally try and zoom out and look at the bigger picture, ignore the lines in the, try and ignore all of this. Do you see how A, B, C, D is a cyclic quadrilateral? It's a four-sided shape where all four corners touch the circumference. It's a cyclic quadrilateral. And the opposite angles in a cyclic quadrilateral add up to 180. So I could work out BCD, because that's then getting closer to the angle that I want, isn't it? BCD would be 180. Don't get mixed up with thinking it's the same number. It's not. They add up to 180. So that would be 114. And then that would be angles, opposite angles, more specifically. Opposite angles, and you'd have to say specifically, I think, cyclic quadrilateral. Add up to or are 180 or equals 180, whatever version of you want to write it. So this is 114. Then I was thinking, this is a straight line. They told me BCE is a straight line, this one here. So I could just work out the opposite side of that. So that would be DCE is 180. Straight line adds up to 180. Minus 114 is obviously then 66 again, isn't it? Now, technically you could write down because angles in a straight line add up to 180, but I don't know if they really need that much explanation. Move it so we've got space, but you can still see it. So technically it's because angles, I'm just going to write it anyway, on straight line. I'm not even writing a full sentence. Okay, now I'm on my last step. So I've used the 132. The only other thing I haven't used is the 16. Obviously, you need to use all the information they've given you. So the last thing is, you see how we've got CDE? That's a triangle anyway, isn't it? It's not even to do with circle theorems. That's just a triangle. So I wanted to work out CDE as an angle, but CDE as a triangle obviously adds up to 180. So that's 180 minus 66 plus 16, which that one I'll probably just chuck in the calculator. Minus 66 minus 16, 98. And technically the reason is angles in triangles add up to 180. So your answer should be 98. I've used 2 circle theorems and 2 just general angles kind of facts. Now I did look at the mark scheme and they did say, so you get, this is 4 marks. They did say that you get 3 marks for your working and 1 mark for the reasons. And I'm pretty sure, if I'm not wrong, sorry, noise again. I'm pretty sure that they've said that you only need to write down, because it's 1 mark for the reasons, that they said as long as you mention 1 circle theorem, I think that's enough for the mark. So I don't know if you need to write all of this. So it's up to you. I would say definitely obviously write down the circle theorems, maybe these two. But I don't think you necessarily have to write down all of this information, even though it technically asks for one reason every stage. Okay, let's see if we can get through. Let's see if we can get through the last questions before the noise comes back. So question 21, the graph of y equals f of x is shown on the grid below. On the grid above, sketch the graph of y equals f of minus x. F of minus x. So you just need to remember what this is. It's just a kind of memorization thing. You've got three options. It's either a reflection, a translation, or an enlargement. Translations and enlargements need numbers. So the fact that there's no number here is already telling me reflection. Then you need to know, is it a reflection in the x or the y axis? Now, it's affecting the x coordinates, which means it's a reflection in the y axis. Okay, so all of my coordinates are going to be reflected here, which means the only coordinates affected are the x coordinates, right? So for example, obviously 0, 0 stays the same, it's on the mirror line. But you see how this one was at -1, it's now going to be +1, but still the same height. So it's basically reflecting across, isn't it? Then this next one is, what's that, -3, 0, so it's going to still be at 0, but now 3 along. And I just pick coordinates that are pretty solid. So up here, then the next one would be this, which is, that looks like -5, and then up the top, so that would be +5, up the top here. And then this side obviously is then going to reflect to the left, so let's say this coordinate here was +1, is now going to be -1. And then that one will go there. So I just map it out, and then obviously just try and join it up as best as you can. Obviously, you'll do a better job than me with your piece of paper and pencil. So that's 1 mark. Part B, here is a sketch of the graph y equals tan x. The graph of y equals tan x. The graph of y equals tan x is translated to give the graph of y equals g of x. So they've translated it, which, if you remember earlier, the other question, it means left to right, up and down. So they basically translated this graph. This is the original. They've moved it up and down, left and right. So following the translation, the point Q here, shown on the graph above, moves to the point R. The point R has coordinates 90 minus 5. So you would need to know what this coordinate is here first. So if you already know the tan graph, obviously you should have memorized it. It repeats every 180, so that's obviously 0. This is 180, and then this one is therefore 360. So the coordinates of Q are 360, 0. Now R is at 90, which is this asymptote, minus 5. So let's say roughly here, let's say that that's R. 90 minus 5. Find an expression for g of x, so the new version of the graph, in terms of x. So we basically just need to apply the translation you know how in the part A they actually wrote it out like this, didn't they? We need to kind of create a version of that to reflect what has happened. So first of all, figure out what's happened. Well, it's first of all moved across. Let's work that out. It's moved across to the left by 270. And, well, the down is pretty obvious. It's 0 to -5. It's obviously gone down by -5. So we just need to know, how do you write that as graph transformations? When you're using trig graphs, you do need to use the tan as well. So it's going to be g of x, which represents y, is equal to tan x. How do we demonstrate that we've moved left? We've translated left. Well, first of all, it's within the brackets with the x, isn't it? But do you remember how x is always the wrong way round? So I know it's gone left, which is technically take away 270. But it's actually the opposite. So it's actually plus. That represents left. Okay, so you have to know that. Now, the y going down, a y-axis translation is outside the brackets, so it's over here. And y-axis is just directly as it is, which means -5. Okay, so you've got to put tan in the brackets x plus 270, which represents going left by 270, and then outside -5, which represents going down by 5. Okay, we're on our last question. Hopefully we can get through this without... Okay, so find algebraically the set of values of x for which x squared minus 49 is greater than 0 and 5x squared minus 31x minus 72 is greater than 0 as well. So this is solving not only quadratic inequalities, but 2 quadratic inequalities. So we tend to solve just quadratic equations normally by factorizing. The first one I want you to recognize, you should be able to recognize this, is difference of 2 squares. So that factorizes really nicely. Just square root the 49. I'm going to put equal to 0 for now, and we'll put the inequality back at the end. So solve it. If you just memorize which way the symbol faces means this type of answer, then we can put the inequality symbols back. When it faces the quadratic, like this one, it faces away from 0, it means you're going to get 2 different answers, so 2 inequalities. You have to put x is less than the smallest number, -7 in this case, and then you have to put x is greater than the biggest number, which is +7. When it faces the 0, it means it's a range, so x would be between those 2 numbers. In this case, it's not. Okay, then we factorize. You can either factorize or you can use quadratic formula to solve the second one. Because this is a calculated question, and this is really not a nice quadratic, like there's quite big numbers, I would probably just go straight into using the quadratic formula because I can't really be bothered to try and factorize it. So obviously that's on your formula sheet. Minus b, now it's already a minus, so that technically becomes a positive, doesn't it? Plus or minus the square root of that b squared. Make sure your calculator does make that positive, otherwise you'll get an error. Minus 4 times a times c. Again, that will become positive because there's double negative there. Over 2 times a, and you just type that all in. What I tend to do with quadratic formula though, is because I know my calculator will sometimes get the negatives wrong, is I kind of work out some of the negatives. So for example, I know that's going to become positive 31 at the outside, and then I'll do 31 squared because I know that the answer to negative 31 squared should obviously be positive. And then here I actually work it out because I know that minus 4 times minus 72 is going to be positive, so I just put plus 4 times 5 times 72. So I kind of work out all the negatives for me, and then obviously 2 times 5 is 10. There we go. If you get an error from doing this, it's because something inside the square root is wrong, as in something has stayed negative when it should be positive, because you obviously can't square root a negative number. So if you get an error, just go back and figure out what's going wrong inside your square root. So we've got, for the positive answer, we've got x is 8, and obviously go back, don't retype it, just go back and change that plus to a minus, and then minus 9 over 5. And again, I need to put back in my inequalities. Again, it's facing towards the quadratic, so that means x is less than the smallest number, and x is greater than the biggest number. So I've done them separately. That's the majority of the marks. The last thing you then need to do is actually figure out a summary, so inequalities that work for both. So you can always use a number line if you want to visualize it, or you might be able to figure it out. So obviously here we have minus 7, somewhere minus 9 over 5. And you have 7. I know it's not to scale, but you get the point. So the first one is like that and like that. And then the second one is like that and like that. So you see where they overlap? I get my highlighter. That overlaps at the minus 7 one, and then this one overlaps at the 8. So my answers, it's going to be two answers, two inequalities again, would be x is smaller than, again, the smallest number is minus 7, not minus 9 over 5. And then the biggest number is 8, not 7. X is bigger than the biggest number. So that's your final answer there. You have to kind of choose inequalities that work for both of the original ones. And that's 5 marks. That's a really nice one if you know exactly what to do. 5 marks. Okay guys, so we made it through. I'm so sorry that the sound at the start and the end of that was really bad. I did not know that they were going to be hammering upstairs. Tomorrow we're going to go through paper 3. It's actually earlier, so hopefully we can avoid the noise. We're actually going to have to do it tomorrow at 5 o'clock, not 7. So we'll try that one out for a week. Hopefully that works a little bit better than today anyway. If not, then I might re-record this myself because I know the noise is really distracting. Anyway, so any of the topics we've looked at today, if I've got videos for them, they will be linked in the description of this live, so you can go through and have a look at actual videos. There won't be any noise in the background of those videos, so if you do need any more explanation, please feel free to have a look at those videos. I've also obviously linked this paper and the mark scheme in the description as well if you wanted to download that, and I've linked the paper 1 live that we did on Monday, part 1, part 2. That's also linked if you want to go back and look at that. There is also a link for a calculator if you haven't yet bought your own calculator. If you haven't got a calculator and you need to start practicing with it, there is a link for Amazon there if you want to have a look at that. Otherwise, I think I've linked down some other videos that you might find helpful. So yeah, let me know in the comments if you have any questions after this live. And thanks for sticking with me throughout it. I know it was kind of annoying with the noise. I'll have to try and see if I can soundproof a bit better. Otherwise, we'll leave it there today, guys, and I'll see you tomorrow at 5 o'clock. I've also got a live on Sunday. I'm going to do an hour on Sunday, which that will definitely be a quiet one, I'm hoping. And that one is just a kind of a general Q&A. So if you have any topics you want to go through specifically, if you have any specific questions you want to go through, I'm going to do a quick live on Sunday. We can do that. So thanks for sticking with me, guys. I'll see you tomorrow at 5 o'clock.